Alright, in this video, I'm going to be going through an answering technique for a very commonly uh, asked type of question. So yeah, the title of this video is Choosing Suitable Values. Um, and why is it titled that way? Well, in this common question type, right, they will give you perhaps they'll give you a circuit, and then you'll see maybe there's like this voltage divider circuit here. There's like two resistors. Or in here there's a one resistor and one capacitor. But then they give you all information you want about the circuit, but they don't tell you what is like the value of the resistances of the components. They don't tell you what's the capacitance. They don't tell you what's the resistance, what's the capacitance. But then they say, let's say in this voltage divider circuit, right, let's say there's a V out, if you don't know. Oh yeah, and if you don't know about voltage dividers, right, you can watch a video on it. I have. But basically, voltage dividers have a voltage output, and then they don't tell you anything. They just tell you that the voltage supply is 10 volts, and they just tell you V out is 6 volts. Then they ask you, with this information, find suitable values of R1 and R2. So then you're just left with that, and you're left with a blank space, 4 marks. So what do you do? Okay, so this video is going to address this issue and then give you a technique basically on how to solve this type of question. So basically, you have two unknowns in your circuit right now, or in your equation. You have two unknowns, and that's always bad. In mathematics, you never want two unknowns in one place, because if you have like in equation 6 is equals to a plus b, a could be anything, b could be anything, and there's no way to pinpoint what's the actual value of a. For example, a can be 1, b can be 5, a can be 4, b can be 2, and whatever. You can't actually get the actual value of a and of b. But let's say we knew the value of one unknown. Let's say b is actually 7, 6, 7. So now you can confidently say, a has to be -1. And the technique to this type of question is like that. Basically, we have two unknowns right now, R1 and R2, and they relate to each other in this equation here, which is the equation for V out, the voltage divider equation. So we can't have two unknowns, because we can never get the actual value of one without knowing the other. So we need to know one of the values for one of the resistances, right? We sub in any value we want. That's the key learning point that you need. And it's very, very simple. Once you know that, right, any question, even if there's 50 unknowns, 50 unknowns, then you need an equation that relates at least two to each other. Okay, but side note, you won't need to know about that. Even if you have like 3 unknowns, you can just sub in values until you have one unknown. So the idea is, if you have 2 unknowns, you have 3 unknowns, what you want at the end of the day, before you continue with your working, is that you must have only one unknown, and then the rest of the unknowns you already put in a number already. So if you don't understand still, because you probably won't, because I'm not actually demonstrating that idea very well. Let's do this voltage divider question right here that I've been staring at for the past 3 minutes. Okay, so they tell us that there are 10 volts supplied to this voltage divider circuit. They tell us that the output is supposed to be 6 volts, and they tell us that R1 and R2 is actually demonstrated in this equation, which so happens to be 6 volts, because see, it's the same, 6 volts. So let's actually rewrite this shit. 6 is actually equals to R2, divided by R1 plus R2 times 10. Then now we reach the issue that I just demonstrated. We cannot have two unknowns. So we let any of those, let's say we let R1, we let R1 be any value. So I'm just going to say I'm going to let R1 be 1 kilo ohm. Okay, 1 kilo ohm. So now, okay, I ran out of space already. Now, damn. The equation will be like this. R2 is equals to 1 kilo ohm plus R2 times 10. Look, we only have one unknown now, R2. We only have one unknown. And then now, we can solve this algebraically already. We can solve this algebraically. So then we just put this over the side. 6. Okay, I'm going to do it like this. I'm going to convert 1 kilo ohm to 1 times 10 to the power of 3. And I advise you to do this when you're calculating. Okay, when you see the prefix, which I've stated in the fundamentals videos, go watch that if you haven't watched it yet. You should just convert the prefix into 10 times 10 to the power 3. So anyway, I'm sidetracking. So we can just do the algebra. This will be 6,000 plus 6R2 is equals to 10R2. We can just shift some things around. 10 minus 6 is 4R, 2, 6,000. And then we get at the end, R2 is equals to 6,000 divided by 4, which is this 1,500, 1,500 ohms, 1.5 kilo ohms. And look, how easy was that, okay? All we had to do is convert our two unknowns, take one, sub in any value, and now we only have one unknown. Just do some algebra, and then we already have R2, we already have R1, and those are our suitable values for R1 and R2. That's the answer. That's how easy, that's how simple it is. Okay? Okay. Let us do another example, okay? So this is a RC circuit. You don't even know what RC circuits is because I have the equation here for you. But if you want to know more, you can watch the RC circuit video which I have. Yeah, so you can check that out. But basically, an RC circuit has something known as tau, a time constant. And that is found by multiplying R and C, as you can see here. Okay, so let's say, okay, we get the question. Then the question says this, okay. In this circuit, the time constant is 6.7 seconds. 6.7. Okay. Then they ask you, find suitable values for the resistance, for the resistor and the capacitor. So, okay, since I've actually already went through the voltage divider circuit, I suggest you, or I encourage you to pause the video here. Then you try this for yourself, okay? Because this is actually very simple. So you can go ahead and do that now. Okay, I'm gonna go ahead and do this. So again, we have this equation. See, tau is the same, tau is the same, So 6.7 seconds is equals to R1 times C1. Wow! Disaster! We got two unknown. Oh, what are we gonna do? Oh, die already. Die already. No. Again, two unknowns. Just sub in the value. Just sub in any of them with any value. So in this case, I'm gonna choose C1. Let C1 is equals to let's say 1 microfarad lah. Okay. Now we can get this R1 times 1 microfarad. Oh, 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 one unknown. Oh, so easy already. Easy already. Because now we just need algebra. This is how simple it is, So when I see your paper, then I see that you get this wrong. Damn saddening because it's so simple. Anyway, normal calculation, we just convert the micro prefix into times 10 to the power negative 6. Then we bring it over here by dividing. And then we'll get R1 already. Damn simple, man. We'll get 67000000 ohms, which is which is 6.7 mega ohms. Okay, because the prefix is times 10 to the power 6, so that would be Deci, centi, milli. Yeah, it's mega. Okay. Before I move on, I actually need to tell you about a rule. Okay. So, whenever you see this kind of question, right, and there's a capacitor involved, generally you want to sub in the value of the capacitor, and most of the time, you're going to want to sub in a value of either 1 microfarad or 10 microfarads or 100 microfarads. Usually you want this, and you don't want to sub in the resistor value. Okay, just follow this rule, and I'll explain why now, but just follow that rule. So once you see this, capacitor involved, 2 unknowns, I have to sub in the unknowns with one of the values, therefore we sub in the value for the capacitor. Okay, the reason why is because resistor values are dime a dozen. Capacitor values are as well, but mostly no. That's just a very shallow explanation, but you're just gonna take it, you're gonna take it in a jar, you're gonna drink it up, right? And you're just gonna follow it. Okay, just follow it. So yeah, okay, that's the rule. Yeah. So and usually I say after doing a practice question, if you got this, then good job, but you can't really copy mine because the way I subbed it in would be have been different from yours. So never mind, I'm sure you can check if you're right. Okay, last question. But in here, wow, got 3 unknown. Oh, I die already. Okay, but no, let me read the question first. Okay, so we got a 555 timer in astable mode. If you don't know what that is, doesn't matter because I got equations here. But if you want to know more, again, you can just watch my video on 555 timers, which I have somewhere. So yeah, I encourage you to watch that if you don't know what this is. But basically, this is a 555 timer in astable mode, which generates a signal that has a frequency. And in the question, they actually tell us the frequency. The frequency is 60 hertz here. Okay. And then that's all the information they give us. Then they say, find suitable values for R1, R2, and C1. And then they also give us that the frequency is this. Okay, so pause now. Try this out for yourself. Okay, so let's start. So I'm going to rewrite this to show 60 hertz is actually equals to this here. Then I realize wow, shit, man, shuckity shucks to the max, man. I have 3 unknowns. Wow, 3 unknowns. Oh no, 3 unknowns, but I can't solve. It's too late. It's over. Then you remember what I said. Okay, we must have 1 unknown only. So we must sub in 1 resistor, we must sub in 1 capacitor, the value, because we must have 2 components. Or it could be resistor and resistor. But remember the rule. Once you see a capacitor, you just sub in the value of the capacitor first. Okay? So I'm going to let R2 be equals to 1 kilo ohm, and I'm going to let C1 be equals to 1 microfarad. And then now plugging these values into the equation, we get this. We get 1 kilo ohm. I'm just going to write in this prefix form. Oh no, I'm wrong. We're finding for R1. So then we'll get 2 times 10 to the power 3. Because it's times 2, and this is 1 times 10 to the power 3, so we can just do the math now. And C1, which is 1 microfarad, which is times 10 to the power 6, minus 6. Okay. Then now, simple algebra again. I say so many times already, bro. Simple algebra. Simple algebra, okay? So, okay, in this case, it's actually a bit complicated, but it's fine. I'm going to start by bringing over the micro... Yeah, I'm going to start by bringing over the microfarad one. So, I'm going to divide this side to this side, and then we get we get 60 times 10 to the power 6 over this side. Then what we can do is we can do a swapperoonie because of an algebra rule. If you have something is equals to a fraction, the denominator of the fraction and that something can swap places. It's just an algebra rule, okay? Or an algebra fact. So we bring this working over here. Now we will get R1 times 2 times 10 to the power 3. 8 times. It's plus. Oh wow, you need to check your work, man. Okay, yeah, I will. Okay, so we get this is equals to 1.44 divided by 60 times 10 to the power 6. So let's find that first. This is going to be an extremely small number, just saying. So we get 24 times 10 to the power of 9. Then now all we need to do is R1 is that number minus 2 times 10 to the power of 3. So we get negative 2000. Negative 2000 kilo ohms. Ohms. Okay, so just look at this. And you realize something went wrong already. This doesn't make sense at all. Because you can't have negative resistance. So okay, what did we do wrong? Yeah, this brings out a very interesting point. So this has to do with the fact with the values we've subbed in. What made this negative is minusing away this 2 times 10 to the power of 3. 2 times 10 to the power of 3 is because of R2 here. That minus, however, is inevitable. So what we need to do is, okay, how about, yeah, at this point you're gonna have to erase everything already because everything you've done is wrong. So in this case, let's sub R1 instead of R2 and then see where that takes us. Okay, so this will make it such that 60 is this. I've already talked through the algebra through the last time, so I'm just gonna do it here. We get 2R2 and we get 1 times 10 minus 6. Then we do the same thing again. Is this 2R2, then we get this. Yeah, let's swap places. So we get 1000. 2R2 1000 plus 2R2 is equals to 1.44 divided by this, which is equals to what, 24 times 10 to the power 9? Yeah. Oh, and then we minus 1000, so we messed up again because we get negative 3000 ohms. So we're gonna have to sub in different values. Instead of oh yeah, so the issue now lies in the microfarad bit. So instead of 1 microfarad, we could probably do with let's try 10 microfarads. So underneath here, it will now be yeah, okay. I'm not gonna write down stuff anymore. I'm just gonna start plugging in values into my calculator, but I'll talk through what I'm doing. So now I'm gonna, oh wait, oh, I've been doing it wrong. As in like algebraically I've been doing it wrong. So what I was doing last time is I was just taking this, okay, I was taking this and then dividing it by everything here. But by doing that is wrong because when you want to bring something over that's in a denominator, you have to multiply. So okay, yeah, so this bit is wrong. Okay, so let's continue on with this chain here and let's see what happens. Sorry about that. Not really, but I don't really. So we get 60 times 10 to the power negative 6. Then from here, we can do a swapperoonie So we will get 1000 plus 2R2 is equals to, oh yeah, it works now. Yeah, so this, then, and that is equals to a very large number, I think. As in like the fraction there. It's equals to a very large number. Yep, 24,000. Then we just need to do R2. I'm skipping some steps here. But R2 is pretty much this. Minus 1,000. So minus 1,000, it will be equals to this 23,000 divide by 2. And then from this we'll get 11500, which is equivalent to 11.5 kilo ohms. So we pretty much solved the equation already, or the question, sorry. Now we have suitable values for R1, R2, and C1 here. So yeah, sorry about that algebraic issue just now. That was my bad. So yeah, that's it. So I hope you learned something from this video, because obviously previously, or I mean if you're not someone from my class, basically right, everyone or a lot of people, like 90% of the people got this kind of question type wrong. So if you're one of those people, I really wish and hope that you learn something from this, because there's a lot to take away here. Mainly the method. Okay, so thanks for watching and bye.